Okay, I'm back.
All right, did I hear you're back?
Yes, yeah.
Okay, fantastic. So we don't need it for the first one, or we're going to actually skip number one. And the reason for that is it would take way too long. We'll come to it at the end if we have time, which I think we might, because actually these are going to go pretty quick. So
Okay.
um, the first one here for part A, you're actually just finding the area of this triangle. Uh, that's what this integral symbol means, this kind of big S, or I don't know, maybe you look at it differently, but it's an area of a triangle. The area of a triangle is 1/2 base times height. Looks like the base there is 8 and the height is 4. Does that look right to you on your, maybe you can
Yes,
see on
yeah.
your, so that is 16. So that is the answer to number one. For number two, it's two triangles. It's this first one and then this little one here. So it's still 1/2 base times height for the first one plus 1/2 base times height for the second one. So that first base, 1, 2, 3, 4, 5, 6, 7. For that first one in red, it's 1/2 7. And the height is, looks like it's 7 again. 2, 3, 4, 5, 6, 7. Yeah. Plus 1/2 the second triangle, the base is 1, the height is 1. So this ends up being 25.
Okay.
49 over 2 plus 1/2, 50 over 2, 25.
Okay. That's
So
easy enough.
this integral symbol, this symbol right here, it means area under the curve. Area under the curve. Okay, we're going to move to number three. Is
Okay.
that okay? Any questions on that?
No.
Okay. Number three, it says find the exact value of the integral using formula from geometry. So if you were to graph this function right here, it would look like a half circle from -10 to 10. And you're supposed to remember from geometry, the area of a full circle is pi r squared. But we don't even have a full circle here. We've got a half circle. So normally it would be half, but we actually only want it from -10 to 0. That's just this part over here, which is a quarter circle, which means what our area is 1/4 of pi r squared.
Okay.
You can visualize this thing going all the way around. That would be the full circle. This is the quarter of it. Is that is that okay? Kind
Yeah.
of. All right. Now the radius is 10. The radius is always the distance out from the center of the circle to the edge, which in all directions is 10. So our answer is 1/4 pi 10 squared, which is 25 pi.
Okay. All right.
All right, that is it for that one. All right, so now to the calculator. All right, so whenever you see numbers on the bottom and the top, you want to go to your calculator and go to math. It's FN int, I think is 9. Let me know if you see that on your calculator. I unfortunately can't show this on the TI that I have here, but let me see if I can find a screenshot of what it should look like.
Okay. F N. Okay, found it.
Does that sort of appear there?
Uh,
I'm just looking for a picture here in case I can't find it. So on your screen, hope does it show you something like this with the box and a
Mm.
box and then D box like that?
Yeah, and then the parentheses and then
And there's parentheses in here.
yeah, and then yeah, right,
Okay.
and then
Okay. So it's pretty straightforward. The one, whatever goes in the bottom goes there. That's the one. The
okay.
3 goes there. 1 plus X is going to go in parentheses. and then x is always going to go there for the variable.
Okay.
So I always do these, I'll do it with you here, but in another tool. So we'll make sure that we've got the same result. All right. What did you get for result?
I got 6.
That is correct.
Okay. Sweet.
So finally, some light at the end of the tunnel
Right.
in this course. And they're not all like that way, but a lot of these are. So this is actually the same thing. You're going to do that math 9 fn int. That's a box, that's a box, that's the box, and then it's always dx like that.
Okay. I got 6.66666.
Okay, so there's another thing. So hit math, enter, and that will convert it to a fraction.
Okay.
And hopefully you get, sorry, I'm a little slow on my side here, getting this 20/3.
Yeah.
All right.
Oh.
Okay, so it's kind of like the mechanic that turns one screw and your car's back together. It's going to be a lot of repetition here, but um, I think most of these can go with the calculator. This one, for example, it says round to 3 decimal places. This one absolutely is done with a calculator. Like you're not shortcutting this. You have to do that with the calculator. Now, I think your calculator will still do this. There might be some issue about how to actually enter this into the calculator. It would be like 12 parentheses natural log of x caret 5. Like I don't know if you can get to the exponent /x.
Okay.
That might be the only sort of tricky thing here to do that. So let me know if there's any issues with that.
Okay.
I can maybe make some recommendations.
Mm, mm. It's not letting me get out of like when I do the natural log, it wants everything in parentheses. It's not letting me like get out of the parentheses except to go to the D, like the box next to
Yeah.
it.
So is there a way to put a fraction in before ahead of time in the I know there's sometimes that feature in that calculator.
Not sure.
Okay, I do have a Smart View 84 thing that I finally downloaded. Let me see if I still have access to it. Oh,
Okay.
yeah, I got some time left on this. All right, let me second quit. Math 9. Okay, let me see here. So can you add parentheses?
Yeah.
Okay. You got it. Yeah, I'm looking at it now. So I guess you have to be creative with how you put this in there. You can go parentheses 12/x parentheses natural log x to the 5th power, close parentheses. I'm kind of seeing that working.
Let's see. I messed it up.
I don't know. Slash back, close parentheses, open parentheses. I'll snip in a picture here if I can get this to work. Okay.
I entered it. Okay, I got 30. Yeah, I got the same answer. Or yeah, 34 point
Yeah.
some.
So you just gotta be creative with how you do that, and we can maybe talk length. But yeah.
Okay.
All right, good. This is good. This will be some help on that final. All right. So use the definite integral to find the area between the x-axis over the indicated interval. When they give you this interval, that's the what's called the A to B. Those are the limits of integration. You're integrating this function. So this is now exactly what you have I've written there. Now there's one little wrinkle here. Let me do one quick check before you enter that in the calculator. Yeah, okay. So there's a little wrinkle to this, which is that you always want it says this comment, it's a check to first see if the graph crosses the x-axis. So the reality is that this graph actually does. So from 0 to 8, it crosses like that. Here at 4, this is 8 and that's 0. What you're supposed to do is break this up into two separate integrals, but you can sort of like work around it by using the absolute value. So if you do the absolute value of 48 minus 3x squared, it will take care of adding the areas together.
Okay.
So what I generally tell a lot of students do is to just use absolute value, just to always put that in.
Okay. Just trying to find it on here.
And if you have any questions, that's also under math, I believe.
Okay.
Oh, what happened there?
I don't see it under math.
All right, give me just a moment to find it.
Okay.
Num. Okay, so it's math, and then you go over to NUM, and it's number 1 for the absolute value. So yours inside that parentheses, you would have ABS 48 minus 3x squared.
Okay, I got 384.
384, I agree.
Sweet.
All right. Next one. So like the previous ones we did, you could have put it in absolute value. Um, you don't have to on these, but when you see that wording to first see if the graph crosses, that's when you have to use absolute value, without
Okay.
understanding why. I mean, but it's because there's some area above and below. This one says the same thing. So when you're integrating here from -3 to 5, you want to do the absolute value of 3x cubed dx like that.
All right, I got 529.5.
Yeah, so that will be accepted. You can also make it a fraction, 1059 over 2,
Okay.
whichever one you think will work better.
Okay.
Right. My cat jumps up every lesson, wants to get up.
It's part of the lesson.
Yeah. All right. Okay, so moving along here. Uh, More of the same. When it says to round, you know that for sure you're going to use the calculator. This one also says to first check to see if the graph crosses the x-axis. That means you're going to use this absolute value of exactly what's there. So that's e to the x minus 4 dx from -1 to 3.
Okay. Okay, I got 15.5437.
Okay, sorry, the thing I'm using is not working very well. Yeah, you said 15.544. I got 15.544. Let me check your rounding on that.
I didn't round tonight.
Okay,
What's
great.
this?
So there's variations on these same problems here, but we're gonna be using the calculator pretty heavily. I wish there was an equivalent for derivatives, but there really isn't. It's only the integrals that this helps out with. So this one here, they're kind of a little deceptive here with the graph. It looks like it's all positive, but then it just drops below the x-axis. So because it crosses, you again have to use that absolute value. 49 minus x squared dx from 0 to 8. Now, if you're wondering why it's 0, it's the left x to the right x. You can think of it as left to right.
I got 236 too.
But so 2010 census gives something about this from 0 to 9 decades. They say 0 to 9 there. So it says find the integral. So just like we've been doing integral um, from 0 to 9. Now, it doesn't say anywhere about crossing, so you can use the absolute value, but if you think in terms of like what the problem is, it's an H distribution, there's not going to be any negatives in there. Um, so it's up to you, but it's you can always use the ABS
Okay.
if you're ever unsure. You can do both and then you feel comfortable. maybe double check that you've entered it correctly, do it twice, once. Actually, you do have to integrate using the absolute value. Wow. Huh, I was wrong. So I didn't expect that, but when I integrated, it gave me a negative number. Just check that I have the right things in there. Yeah, so you actually do need to use absolute value on this.
Re-enter it. I got 254.484 the first time without the absolute value.
Yeah. Oh, you did get that?
Yeah. And I didn't use the absolute value.
Yeah. Why is mine wrong? Uh, oh, I see what I did. I put in the wrong function. All right. So I take that back. You don't need the absolute value.
Okay.
That 254 number is in the problem down here. That's a good sign when you see that. So yeah, we'll call that 254. So it says, what does it represent? About 254. Okay. So it's going to be about 254 million. So about 254 million, age 0 to 90. No, X-rays, age distribution. Okay. It's the integral gives you the total number of people 0 to 90, which is about 254 million. The part B, it says, find the number of people who are alive because they were born in the 60s. That is, those are in the range of 3 to 4. So that's the same thing we just did. It's the integral from 3 to 4 instead of 0 to 9. 3 to 4 have that 40.3 plus 2.17x minus 0.807x squared. You can use the second entry. Entry is the enter above enter there to recall the previous line, and that might make it easier to edit rather than retyping it.
It didn't work.
So you may have to just restart there. Let me second quit.
I got 37.942.
To round to the nearest integer, so we'll say 38 million.
Okay.
Okay, we're doing great. Yeah, moving right along here. So these get a tiny bit harder with these. They give you less information. That says to find the area between the curves. So graphically, like this is the x squared, this is the 8x. There's two intersection points, and they're telling you one's at -2 and one's at 2. So those are the bounds of your integral. It's -2 to 2. Now you're supposed to do top minus bottom. Sometimes you don't know or you're not sure. So you can always use absolute value. Meaning like if you don't do the right top and the right bottom, you're gonna have an issue. But if you do absolute value, then it doesn't matter. Okay. So just to prove this point, you can see graphically the top is the line 8x. Let's make that the bottom. And let's do this x squared minus 9 as the top. So if you do this integral from -2 to 2, you'll get the same thing as doing the top minus the bottom. So go ahead and give that a try, please.
Oh shit, sorry, I forgot to put the absolute value in it. One moment. Okay, I got 41.3333.
Yeah, 124.3.
Okay.
You want to enter that. That's the math enter
Right.
if you need to. Okay. Next problem here. So the this one's different because you don't have the intersection of them. And that's what makes this one more difficult. So one way to find the intersection is to graph. Okay, I don't know where those points are, but that's one way to do it, is to find the intersection graphically. The second option is to set the equations equal to each other. Which way do you think you will do on the test?
Probably the second one.
You said the second one? Okay. So we'll do that together. So if we add 3x to both sides, subtract 7 from both sides, we get x squared plus 3x minus 40 equals 0. And then you have to two numbers that multiply to negative 40 adds to positive 3.
Um, um, 5 and 8.
One's positive, one's negative.
Oh, right. +8, -5.
Great. All right, so that's you set them both equal to 0. And then it's -8 and 5. So those are the integrals. And then it's the same thing. You're supposed to do top minus bottom. So this time we'll actually use the correct top, which is 7 minus 3x. But when you subtract the bottom, you have to put it in parentheses.
Okay.
Okay. Now you can still use the absolute value if you want, but you don't need to.
Okay, I got 366 point. Let me put it into fraction.
Let me I think it's working well. All right. So integral
I got 2197 divided by 6 for the fraction.
from, yeah, so let me show you briefly, really briefly. So I did the wrong order in this piece of software I use, and you'll notice it just gives you the negative of the right answer. Okay, we're doing really well. Last of these problems, and we'll have time to go back to number one. So this is, well, again, like it's more like the one we did before the problem. They give you the two bounds. You don't know which one is the top or the bottom. So you just do the absolute value. You go integral -1 to 2, absolute value, um, 3e to the 3x minus parentheses 2e to the 3x plus 1.
Forget the absolute value. And I got okay. I got 132.82.
We get slightly different. Three, three. Maybe you left out a parenthesis. Maybe I left out something.
Okay.
We want to have the same answer. We don't want to just,
Right. 2 -1. I typed it in exactly how it's written, how you wrote it.
yeah, I'm looking at it now. I'm trying to be like, where is the difference?
Yeah.
Do you have absolute value in yours?
Yeah.
Hmm. Uh, oh boy. Let me find another tool, I guess. We'll let that settle the debate. Oh boy. Why can't we just always something? -1 to 2. All right, so we got right, so this one gave me the exact answer, and then I'm gonna just go to the calculator. Yeah, I got the same result. I mean, if you want, you can send over a picture of your calculator. I can, but I would recommend using this result.
Okay, that's weird.
Uh, all right, so we have one more question. Let me go grab it here. All right. So there's this idea here of how to do these like left, right, endpoint calculations. The way to do it is you first have to figure out what's called this delta x, which is b minus a over n. This is a, this is b, this is n. So it's 2 minus a minus 2 over 4, which is 1. And so what you do is you actually end up writing these minus 2, minus 1, 0, 1, and 2.
Okay.
Now, why the reason I'm doing this, we're going to get the answers pretty quickly, um, is for the left endpoints, you use these. The right endpoints, you use these. So for the left, the area formula is you take your delta x, which is 1, and you find f of negative 2 plus f of negative 1 plus f of 0 plus f of 1. So it's putting those numbers back into this equation here. So you have to get like negative 2 squared, negative plus 10. You end up getting 4, 9, 10, and then 9, like that for your left one. For the right, it's very similar. It's f of negative 1 plus f of 0 plus f of 1 plus f of 2. What actually ends up being the same, it's because this thing is symmetric. That's okay. So that's 9 plus 10 plus 9 plus 4. So what do we got here? 2832. Does that look right to you?
Yes. Yeah.
All right. So that's the first two boxes, 32 and 32. The average is 32.
Right.
And then the next thing here is the midpoint. This one's way worse. You end up using the midpoint between these minus 1.5, minus 0.5, 0.5, and 1.5. So you can't actually reuse any of the values. So for the midpoint, it's again delta x times f of negative 1.5 plus f of negative 0.5 plus f of 0.5 plus f of 1.5. Now, because of symmetry, you get a little help here with that, but it's minus x squared plus 10. So this ends up being 7.75. 9.75 plus 9.75 plus 7.75. So by symmetry, these end up being the same.
Okay.
Any questions on that?
No.
I think we got everything done.
Okay. Submit. All right. We looks like the last two were not right that we
Oh,
did.
no, I'm so sorry. You can definitely look at those another time. This one may not have wanted absolute value. Not sure.
Okay.
Maybe I just wasn't paying attention. I apologize. But